Voyager to turn its camera back towards Earth, and it's what basically amounts to Earth's first ever selfie. And that picture was taken, and there was this pale blue dot.
Voyager 1 has begun sending mysterious signals to Earth, signals that NASA has officially labeled as abnormal. Together with its twin, Voyager 2, this legendary spacecraft has revolutionized our understanding of the outer solar system and has even ventured beyond into interstellar space. But what exactly is happening to Voyager 1 now, out in the cosmic depths? Could we be receiving a response to the Golden Record? Or has it somehow come under the influence of an extraterrestrial civilization? Voyager 1 and Voyager 2 have traveled unimaginable distances since their launch in 1977, approximately 24.91 and 20.84 billion kilometers from the Sun. No other human-made object has ever journeyed this far into space. As they moved beyond our solar neighborhood, they collected data that remains unique even today. Yet these spacecraft weren't originally built to exit the solar system at all. Their main mission was to explore the outer planets, regions that were still largely unknown back then. To say they fulfilled this mission would be an understatement. Voyager 1 and 2 set countless milestones. Voyager 2 remains the only spacecraft to have visited all four gas giants, Jupiter, Saturn, Uranus, and Neptune, making it the first and only mission to explore four planetary destinations in one journey. Its close flybys of Uranus and Neptune revealed extraordinary findings, like their unusual quadrupolar magnetic fields and massive icy mantles beneath dense atmospheres. These insights gave us a new understanding of the ice giants. In addition, the Voyager probes were unmatched when it came to moon discoveries. Together, they added dozens of new natural satellites to our maps, 3 new moons around Jupiter, 4 around Saturn, 11 around Uranus, and 6 around Neptune. One of the most groundbreaking discoveries came from Io, a moon of Jupiter, which Voyager 1 revealed to have active volcanoes, the first observed beyond Earth. Voyager 1 was also the first probe to capture lightning in Jupiter's atmosphere, while Voyager 2 gave us the first images of the rings of Uranus and Neptune. Moreover, Voyager 2 provided the first clues that Europa, another of Jupiter's moons, might harbor a hidden subsurface ocean, a potential cradle for extraterrestrial life. But what lies beyond our solar system is even stranger. As groundbreaking as their planetary discoveries were, they're now considered old news. Today, both spacecraft are venturing through interstellar space, uncovering new and puzzling phenomena. To understand their findings, we first need to grasp some basics about our cosmic environment. The Sun is not a stationary object. It's a fiery nuclear engine hurtling through space at roughly 725,000 kilometers per hour. Around it stretches a vast region of influence known as the heliosphere, formed by solar winds, streams of charged particles emitted by the Sun. These winds don't mix with the interstellar medium, which consists of ancient particles, magnetic fields, and radiation left over from the Big Bang. Instead, they create a protective bubble, the heliosphere, extending around 18 billion kilometers from the Sun. At the edge of this bubble lies the heliopause, the boundary where the solar winds meet interstellar space. This is where true interstellar space begins. When Voyager 1 crossed this boundary in 2012, the data it sent back stunned scientists. The interstellar magnetic field was found to be 2 to 3 times stronger than expected, and the pressure from interstellar particles was nearly 10 times higher than anyone had predicted. Yet the data had a drawback. Voyager 1's plasma instrument had failed back in the 1980s. Thankfully, Voyager 2 still had a functioning plasma detector. So, when Voyager 2 crossed the heliopause in 2018, it provided much clearer insights. As it approached the heliopause, Voyager 2 recorded plasma that slowed down, became denser, and increased in temperature. However, even then, the plasma around it was cooler than expected, though the interstellar medium itself was revealed to be much hotter, at nearly 30,000 degrees Celsius. Intriguingly, data also showed that plasma from both inside and outside the heliopause could cross into each other's regions. Scientists observed a stream of low-energy particles extending 160 million kilometers into the heliosphere. One more surprise came during each spacecraft's final approach to the heliopause. Voyager 1 entered a relatively static zone where solar wind had abruptly slowed down over a distance of 1.3 billion kilometers. In contrast, Voyager 2 encountered a far more dynamic environment, highlighting how even the edges of our solar system can differ dramatically depending on location. Heliophysicist Patrick Kahn, a program scientist at NASA headquarters, captured the bewilderment of the scientific community with a simple but powerful statement: "This is really quite strange. It proves to us that we absolutely need more data." This comment not only reflects the different findings from the two Voyager probes, but also highlights how incomplete our understanding of the heliosphere still is. In fact, scientists aren't even certain what shape this massive structure takes. It could be spherical, or perhaps shaped like a croissant. Some even believe it might have a long, comet-like tail. But the mystery doesn't stop there. One of the most unsettling incidents in the Voyager 1 mission occurred just a few years ago when the spacecraft began transmitting a baffling stream of data back to Earth. The data was incoherent, nonsensical, completely out of line with expectations. Naturally, once the news went public, the internet erupted with speculation. Some believed the probe had been hijacked by an alien civilization. Others imagined it had been reprogrammed by extraterrestrials and sent back to Earth with a warning, or worse, a declaration of war. So what really happened? Thankfully, the world has not been plunged into an intergalactic conflict, but even NASA's top engineers were initially puzzled. The signal being received seemed random, almost as if it were coming from a malfunctioning system. The data in question originated from Voyager 1's Attitude, Articulation, and Control System, or AACS, which is responsible for maintaining the spacecraft's orientation, including keeping its main antenna pointed precisely at Earth. Despite the strange telemetry, Voyager continued to respond to commands from Mission Control. The radio signal strength remained unchanged, suggesting that the antenna was still properly aligned. The scientific instruments aboard the spacecraft were also functioning normally and continued to transmit valuable data. So what was causing the strange transmissions? Eventually, NASA engineers managed to pinpoint the issue. They discovered that the AACS itself was still operating as expected, with one major exception. It was sending telemetry data through a computer that had been out of commission for years. Since this computer was no longer functional, the data being relayed to Earth was nothing more than unreadable digital noise. Once the cause was identified, NASA used the Deep Space Network's radio antennas to issue a new command. They instructed the AACS to route its telemetry data through the proper functioning computer. This worked perfectly. Normal data transmission resumed, and Mission Control once again had access to consistent, reliable telemetry. But one lingering question remained. Why did the AACS start using the wrong computer in the first place? At first, engineers could only speculate. One theory suggested that another faulty component might have issued a bad command. Over time, further investigation revealed that the source of the problem likely lay within the flight data subsystem, a computer responsible for formatting and packaging data before transmission to Earth. NASA discovered that around 3% of this computer's memory had become corrupted. The most likely cause? A single, aging chip that had either been struck by a high-energy cosmic particle or had simply degraded after decades in space. And just like that faulty chip, the universe reminds us that even the most advanced technology is vulnerable to time and the elements of deep space.